So you've probably heard the phrase, you matter, to describe the importance or the value of both yourself and those around you. So while that is a very true phrase, we can make one small change to it and still have it be a valid statement. You are matter. So let's go ahead and investigate this second description. So, chemistry is the study of matter and how it changes. And quite simply, matter is anything that takes up space and has mass. So, it has to have a volume, takes up space, and then it has to have mass or some heft associated with it. In other words, think about the fact of whether or not you can hold it in your hands. Okay, so if you can hold it in your hands, it's a physical object, it's probably matter. If it's something that you can't hold or touch, then it's usually not. Let's go ahead and try this out with some examples, both of what is and is not matter. So something that is matter would be a light bulb. Okay, we have the glass, we have the metal, it has a mass to it, we can hold it and touch it. Something that is not matter would be light. So light is actually made of photons, which are little packets of energy. So it doesn't have a mass associated with it, and even though it travels through space, it is not considered to be matter. Another example is your pet. So I have a dog, his name is Gilbert, and I love him very much. Now, Gilbert has mass and he takes up space, a lot of space sometimes, but my feelings towards him, the love and caring I have for my dog, is not an example of matter. It's not anything I can touch, even though it's really important. And then some more examples, rain or water. These are things that have volume and they have mass associated with it. But a rainbow is not matter because if we think about it, you can never touch a rainbow. It is just how the light bends as it passes through raindrops that creates that split or that prism of color light that we see. So there's no actual mass to it. We can't touch or hold the rainbow, so it is not matter. Okay, so here are some examples. I want you to go ahead, read through them, think about it. If it is an example that is of matter, go ahead and circle that word or that phrase. If it's not matter, just go ahead and move on to the next one. So go ahead, pause the video for a few seconds and try this on your own. Then we'll go over the answers. Okay, so the first one, a radio. So hopefully you recognize the fact that you can go ahead and touch a radio. It has mass, it takes up space, so it's matter. Air. This one can be a little bit tricky, but air is actually made up of atoms and molecules. So we have oxygen and nitrogen gas. We can actually feel the air impacting us as we have a windy day and we have those changes in pressure currents. We can also, when we blow up a balloon, we can see the air that we're expelling, helping to inflate that balloon, having volume. So air does have mass, it does have volume, it is matter. Now, heat. Heat is something we can feel, but it doesn't have mass, so it is not matter. A textbook. This one's pretty obvious, hopefully, that we can touch it, we can have its volume, we have its mass, so it is matter. Now, fire. This one's sometimes a little tricky too. So if you think about fire, it takes up space or it seems to occupy space, but it doesn't have any mass associated with it. And in this case, I'm talking specifically about the flames. Now, the wood or whatever it is that's burning, that would be an example of matter. But the flames itself are just a sign that a chemical change is occurring. So fire is not matter. Similarly, thoughts, they just occupy space in our head. They do not count as matter. Radio waves also do not count as matter because they have no mass. So that's what helps to transmit the information from the radio station to our radio so we can listen to our favorite songs. But again, there's no mass. It doesn't count as matter. And then finally, you. You, of course, do matter, but you're also made out of matter because you have mass and volume. Okay, so we're going to talk about different states of matter. We're going to talk about the three most common ones. Now, there are many other states of matter. It's up for debate exactly how many there are depending on who you talk to, but we're just going to focus on the three that we really interact with on a daily basis. So the first one is, of course, solid objects. So solid objects have a defined volume, so it always takes up a set amount of space, and a defined shape. This is because the atoms are tightly packed together. They touch one another. If you see in that picture there, they can vibrate a little, but they can't really move around any. They're kind of stuck in one location. So because they can't move, they have a defined volume and a defined shape. Now liquids, those atoms are a little bit further apart. So because they're further apart, they can change their shape. But they still like to be close to their neighbor. There's still an attraction kind of holding them together. So they have a defined volume, but they do not have a defined shape. So they will actually change the shape based upon what container they are in. So an example of this, if you have a gallon of milk or water or juice, whatever your favorite beverage is, if you take that gallon jug and you pour it into 8 different cups, you still have a gallon of that beverage. It doesn't change the volume, but the shape of it did change. And then finally, we have gases. So for gases, the particles are very, very far apart, much further than is depicted here in this picture on the screen. The atoms are able to move really fast and they're far apart, so they don't have much attraction between one another. So this makes gases the most variable. Their volume is going to change to fill the container, but they're also going to take the shape of the container. And that's because there's so much space between those particles. They basically act like individual atoms. They don't notice that anything else is around them. Okay, so while we have those states of matter, we also need to think about how we change. So remember, chemistry is how matter changes. So one way we can have matter change is the phase or the state that it is in. Okay, so with phase changes, we can move between being a solid, a liquid, and a gas, usually by changing the amount of energy or heat that we put into a substance. So if we take a solid and we add extra heat or energy to it, we're going to go ahead and liquefy it in a process known as melting. We can then add additional energy to that liquid and get into the gaseous state through a process of boiling or evaporation. So boiling is when we actually reach the boiling point. That's like when you're boiling water for spaghetti, versus evaporation can occur at lower temperatures. So evaporation is when you hang a wet towel over the laundry line outside. The water evaporates off, it goes into the gaseous state, but we're not actually heating it up as much as we would be with boiling. Now, when we go from the gaseous state to the liquid state, we're removing some of that energy, we're cooling it down. That is condensation. So that is what you see when you have dew on the morning grass after it cooled down overnight. And then going from the liquid to the solid state is freezing. Now, these are actually not the only phase changes we can see, although they're the most common ones that we experience. There's actually 2 more common ones, which are going directly from the solid to the gaseous state or the gaseous state to the solid state. We do not form a liquid in between. So going from solid to gas, this is an example of dry ice. So dry ice is frozen carbon dioxide. When we heat it up, it actually doesn't form a liquid, it goes directly to the gas phase. So this is a process known as sublimation. Now, if we take that gas and we cool it down, this is something called deposition, when we go directly from being a gas to being a solid. So we can actually do this with iodine. So iodine forms a vapor. If we expose it to a cold surface, it will actually form little solid crystals on it. So the way that I remember it, if you think about the word deposition, it has the word deposit in it. So you're depositing a solid, you're putting it down. So just to quickly recap, we started off the video by explaining what chemistry is and matter and gave examples of that as well. And then we talked about the 3 main states of matter, what they are, how to describe them, their pictures, and then also phase changes for those different states. So if you have any questions on this, please let me know. But remember, you matter.